Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's actually a collection of 3 puzzles. I guess the combined difficulty of them is hard, but I don't think they're that difficult. But there are multiple ones, so I think that that's why it's rated hard difficulty. And they are a group of chaos construction doppelganger puzzles. And the first one's called Duck Soup. The next one is called Sawtooth. And the last one is called Travelers. And so we're going to do this set of 3 as a set of 3 puzzles. And I will be linking each of them in the description. Anyways, let's get to the puzzles and the rule sets. So they are chaos construction, all of them, and you need to divide the grid into 6 regions, each made of 6 orthogonally connected cells. The regions and the grid as a whole must follow the doppelganger rules as described below. So for chaos construction, you must divide the 6 by 6 grid into 6 regions of 6 orthogonally connected cells. What does it mean to be orthogonally connected? Well, that means you have to be able to connect from must be able to go from one cell in the region to another cell in the region just by going through edges, all while staying within the region. So for example, this is a valid example of an orthogonally connected region. This is not, because to get from this cell to any other cell in the region, you have to go either through a corner or go outside of the region through an edge, which is not allowed. So that is chaos construction rule set. Also, the digit in the top left cell of a region, that is its leftmost cell on its highest row, is its region number. All region numbers must be different, and together they must form a set of the digits 1 to 6. Well, that makes sense, because if they must be different, they have to be all unique, and you have each of the regions having 6 regions, right? So they have to have all unique regions. So all of the region numbers, which is again the leftmost cell of the topmost row in the region, is the region number. So in this region, it would be this cell, which is the leftmost of the topmost cell of topmost row of the region. And this would basically be the region number. So if this were, say, a 6, say this was a 6, then therefore the region number for the pink region would have to be 6 here. Oh, okay. Actually, that's not correct. That it would necessarily have to be just different. It is important that they must form a set of the digits 1 through 6, because you can also have 0 in this puzzle. So keep that in mind. The region numbers can never be 0. They have to be different, and they have to be non-zero. So keep that in mind. I think that's the same for both Sawtooth. Okay, so that's not actually... So the region numbers is only for Duck Soup and not Sawtooth or Travelers. But the chaos construction rule set is common amongst all 3 of the puzzles. So you need to divide the grid into 6 regions, and the regions and the grid as a whole must follow doppelganger rules. And that is the same for all 3 puzzles. The digit in the top left cell of a region, which being the region number having to be different, is only in Duck Soup. And I think all of these are the same. Yes. So aside from the region number for Duck Soup, all the rule sets are exactly the same. So we'll just go through them. So what is doppelganger? Well, in Doppelganger Sudoku, every row, column, and region contains the digit 0 always, as well as 5 out of the 6 digits from 1 through 6. That is, it's missing one digit that is non-zero. No two rows, no two columns, and no two regions may be missing the same digit. So, for example, say you're missing a 1 in row 1, you cannot be missing a 1 in any other row. Therefore, you must have essentially the set of 1 through 6 in this set here. These are the missing digits in rows 1 through 6, respectively. These are the missing digits in columns 1 through 6, and this must be the missing digits in regions 1 through 6. And they must be missing different digits in every row is missing a unique digit in the puzzle for all the rows, right? So you have to be missing essentially the digits 1 through 6 in rows 1 through 6. You must be missing the digits 1 through 6 in columns 1 through 6, and once each. And same for the regions. Also, in addition, say this was a 0 here, and say we were missing a 4 here. The region that this was in would be pink, and you cannot be missing a 4 in the pink region because the 0 in that pink region is already missing a 4 in its row. And you must be missing the digits missing in its... Okay, for each 0 in the grid, the digit missing in its row, its column, and its region must be 3 different digits. Yet zeros always have a null value that is 0. Okay, I don't know why that's put in. But basically, so for example, for this 0, that's in the pink region, in row 3, you'd be missing a 4. You could be missing a 4, say. You could be missing, like, say, a 1 in column 4, which is where that 0 is. And in the pink region, you could be missing 5. And this would be valid because for the pink 0, you're missing a different digit in its row, its column, and its region. You cannot have something like, say, 4 and 4 in one, because then in its region, it would be missing a 4, and in its row, it would be missing a 4, which is the same digit. It has to be missing 3 different digits in its row, distinctly in its row, in its column, and its region. And then finally, we have Renbands and German whispers, where each purple line must contain a series of consecutive, non-repeating digits which can appear in any order. So you could have something like, say, 0, 2, and 1, and this would be valid because this forms a set of consecutive repeating digits. Consecutive non-repeating digits. 0, 1, and 2 is consecutive, and there are no repeats on the line. But you could not have something like, say, 4, 2, and 1 here because that doesn't form a set of consecutive digits there. Adjacent digits along a green line must differ by at least 5. So adjacent digits, so say this was a 6 here, that would mean this digit would have to be 0 or 1 here, because those are the only digits out of 0 through 6 which are 5 or more away from 6. And I don't know if this is going to be common for all of them, but regardless of the type of line, the two ends of each line must belong to the same region. So this is not a valid region here, because the end of this line here and the end of this line here, the ends basically are not in the same region, and they have to be part of the same region. Let's just check for Sawtooth. Yes, Sawtooth also has the same restriction. Okay, and Travelers has a slightly different rule set for Renbands. They do not have German whispers on Travelers, but they have an extra rule set. So we have on travelers specifically, the digit in a dot is exactly one less than the number of different regions that its Renban line travels through. Okay. So the digit on the dot is exactly one less than the number of different regions that its Renban line travels through, and no two dots may contain the same digit in travelers. So, for example, say this was a region here, and this was a region here, and this was a region here. Then this dot would have to be one less than the number of different regions that the Renban line travels through. So this would have to be 2, which is 3, which is the number of different regions that the Renban line travels through, minus 1. And say this was yellow, and we had blue here, and this is orange. So this travels through 1, 2, 3, 4 regions. So this must be 4 minus 1, which has to be 3. And on this puzzle, in Travelers, no two dots may contain the same digit. So all of these dots have to have different digits in them. And those are all the rules across all the puzzles. There are 3 puzzles: Duck Soup, Sawtooth, and Travelers. And as I said, I will link all 3 of the puzzles in the description. And now I'm going to get started. Let's go. Okay. Let me take a sip of my drink. Okay. For each line, they have to be part of the same. The endpoints have to be part of the same region. Well, one interesting thing about German whisper lines, or as I like to call them, whisper 5 lines, and again, this is not for my own aggrandizement. A setter came up with the name of this, and I thought it made a lot of sense because you can expand that beyond Whisper 5 to like Whisper 3, Whisper 2, Whisper 6, all those different types of lines. And it makes sense. But for the digits 0 through 6, the only digits which can be on a Whisper 5 line is 0, 1, 5, and 6. So this has to be 0, 1, 5, and 6 on all of these lines. Right? Those are the only possibilities. Okay. Which means we have 4 digits in row 5, column 3, and column 5, which must contain the digits 0, 1, 5, and 6. Now, which digit can be between 2 unique digits on a Whisper 5 line from 0 through 6? Only 0 and 6 can be, right? Because if you have 1, that can only be next to 6. 5 can only be next to 0. So this has to be 0 or 6 here, because it's between 2 unique digits. This must be 0 or 6. That eliminates 0 or 6 in the remaining digits in column 4. That means this is 1 or 5. 1 or 5 has to be next to 0 or 6, respectively, right? If it's 5, it's next to 0. If it's 1, it's next to 6. So I'm going to choose random colors then. These have to be opposite colors. So we're going to mark this as yellow and this one as orange. So that means you'll alternate between sets because on a Whisper 5 line, in normal Sudoku, But also in this modified version, this doppelganger Sudoku, from 0 through 6, it's going to be really restrictive. You're going to have one set being 0, 1, the other set being 5 and 6. So this is going to be orange, which is next to yellow and yellow, which has to be next to an orange. So this is yellow next to orange and orange. This is 06. We don't know which ones these are. So remaining digits in column 3 are 2, 3, and 4. Oops, 5, 6. I don't know how I get that. 2, 3, and 4, and the missing digits also 2, 3, and 4. Same with column 5. 2, 3, 4, 2, 3, 4, and this is 2, 3, or 4 missing. Same with row 5. 2, 3, 4, 2, 3, 4 missing. This has to be yellow. That means where this is yellow, we have orange, and this must be yellow. That makes this orange, which makes this yellow, which makes this orange. So this must not be the yellow 0, 6, it must be the 1 or 5. 1 or 5 has to be next to the orange 0, 6, so this can't be orange 0, 6 here. This is orange 1 or 5. This is next to both orange 1, 5 and orange 0, 6. So this has to be the yellow 0, 6, which eliminates 0, 6, 0, 6 as a pair in column 5. And this must be then the orange 0, 6. This is the yellow 1, 5. This is yellow 1, 5, so this cannot be yellow 1, 5. It's yellow 0, 6, which means this can't be yellow 0, 6. It's yellow 1, 5, which has to be next to the orange 1, 6, or orange 0, 6. This cannot be orange 0, 6. This is orange 1, 5, which eliminates 1, 5 here. This can't be orange either way because we have both the orange 0, 6 and the orange 1, 5. So this is yellow, which makes this orange. Okay. This is orange 1, 5. So yellow 1, 5. So the yellow 0, 6 is here. Let us see. It must belong to the same region. So this is the same region. This is the same region. These two are the same region. Okay. So that means this cannot go this way. This has to connect through this way. So this is a boundary here. Because these two are part of the same region. These two are part of the same region. These two are part of the same region, so there's a boundary there. Could you go around? 1, 2... 1, 2, 3... Oh, these are part of the same region. So there's boundary here. So these are part of the same region. These two are part of the same region. So this has to go this way through this region. This is a different region. These and this are part of the same region, so it has to connect orthogonally that way. So this cannot go through here to get through here. So this is all part of the same region. Therefore, there's a boundary between these two. These two must go through here because it's blocked by this. Hmm. So here in row 1, we're missing 1 through 5, possibly. In row 2, we're missing 2, 3, 4, or 6. We're missing in row 4, 1 through 5, because we have 0, 6 as a pair. 2, 3, and 4 can never have a 0 next to it. This has to be 1 through 5 here. Remaining digits in column 4 are 1 through 5. So we're missing 1 through 5 here in column 4. 2, 3, and 4 does not have a 1, 5 pair here. So this must be 2, 3, and 4 because it can't extend beyond 2, right? You can't go 2 to 1 because you don't have a 1 because of the 1, 5 pair of which are required in the column. So this has to be a 2, 3, 4 triplet here. This then is missing 2, 3, 4, or 6. This cannot be 1 or 5, but this could be. So this could technically be 0, 2, 3, 4, or 6. And this could be a lot of things here. So the digit in the top left cell of a region is different, and it cannot be 0. This one could go up to there. Okay. This cannot be 1 or 5, so we have 0, 2, 3, 4, 6 here. So, okay. I guess this could be a region. We know these two are part of the same region. So this can never be 0 here. This would have to be 1 through 5. It cannot be 6 here. Oh, yeah. So this is 1 through 5, 1 through 5 remaining in row 1. If orange is 0 and 1, that would mean these have to be 0, and this would be 0, and that would be 0. And this would have to be orange 0 or 6 in that case. If we have yellow as 0 or 6, that would mean this would have to be 0 here. This would be 0, this would be 0, 0, and 0. And we would have to have 2 yellow 0. We'd have to have a yellow 0. This would have to be yellow 0 here. And you'd have to have yellow 0 be here then. Okay. Hmm. Hmm. Uh, remaining digits in row 4 are 1 through 5. Hmm. Hmm. So these are the same region. So it could be part of this region, or this is part of this region, or it's part of this region. Those are the only choices. These are obviously part of the same region. So are these two. It cannot cut off, so this must be a full part of its own region, right? If we tried to have these as separate regions, then this is part of a separate region. It would be blocked from any other region. So this must be a full region here. Same with this. Huh. You could have a full region like that. That is possible. You cannot have a full region as a complete row or column. That's one thing we know. Because if you do, then the 0 in that row or region would basically be missing the same digit as the region, right? In the row, you'd be missing the one digit. Okay. Oh, interesting. This is part of either this region or this one, right? There's no other way that to connect those two. except through this one or this one. And this one is definitely different. 1, 2, can it be part of this? 1, 2, 3, 4, 5, no, 6. If it's part of this region, that fails. Right? Because it's guaranteed to be 4 already. That's 5 and 6, and we need a 7th to connect orthogonally. So it has to be part of this region here. So this is 1, 2, 3, 4. It cannot connect to this because that would be 7 also. So this is a region in itself. So let's mark that as red. These are part of the same region. Therefore, it must get to here. So it's green. This is all part of the same region. So this is a border. This is a border. So this is at most 5 in length. So it has to be connected to here. So then this must be part of the same region. So that's all one region then guaranteed. So this must be part of this region here. This is green. This is then the uppermost, the leftmost of the top row of that region. So the yellows, 0, 6s, have to be 6. So those are all 6s. We can remove the yellows. These are all 5s then. And we can remove the yellow. And this must be 5 or 6, and this has to be 0. So all the oranges are 0 and 1. And all the left ones are 1. So this cannot be 5. This is 0. So this can't be 0 here. Where is the 0 in? This can't be 0 because of 0 in the row. Where is the 0 in row 6? It has to be here. So this is 0, which means it has to be with 6 here. This 5 eliminates 5 in the rest of the columns. Okay, we can remove orange. So this is pink as a region. This is blue as a region. Sorry, this is green as a region. So this is done. This has to be essentially orange. And it cannot go here and then here, because that would be too big. So this is a separate region. So this must go orange at least here. This has to go out. So this must be a separate region. And orange has to continue to here. So this must be all... This must be a separate region. And this must go out to, well... So this is done as a region. Can this ever be part of red? The answer is no. Can it be part of yellow? The answer is no. So this must be part of blue. So guarantee this is blue. This could be part of blue. So this is either both blue or both. So it has to go both blue here. It could just go one blue here, technically. So one of these is blue, the other one's red. So this is blue or red, we're not sure which. This is blue or red. Yellow can only go one here at most, so yellow has to go here. So this could be yellow or blue or red. This could be yellow or red. And this, can this be blue? No, we have 4 blues already here. So this cannot be 1 here because of 1 in the blue region. Can't be 6 because of 6 in the row. So we're missing a 1 in row 6. Which means we're not missing a 1 in any other row. This can't be yellow. We have already 5 yellows here. 4, 5. So this is red or blue. We have a 1 here. We must have a 1 in one of these. This is missing. This is 1 is eliminating 1 here. We need to have a 0. So I think, can this ever be blue? Red, 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 red. Yeah, it could be. Could be blue. We have 6, 5. So 6 is the region number for that. 5 eliminates 5, the rest of row 1. So this cannot be 5, 6, and 4 here as a red band, so this can't be 6. We have a 1, 2, 3, 4 quadruplet in the green region. So let's do the regions. We have green, orange, or pink, orange, red, yellow, and blue. So this has to have a 3 here because these are on a red band, either 2, 3, or 3, 4. So this cannot be 3 here. So this must be 3 on this red band, and this is 2, 3, 4, which means we're missing a 6 in column 6. That means one of these is 3, so this cannot be 3 here. We're missing a 6 in row 2, because we have a 2, 3, 4 triplet there. One of these is 1. So as a red band, this is either 1, 2, 3 or 2, 3, 4. So this cannot be 2 or 3 here. This is 1 or 4 there. In the green region, we're missing 5 or 6. In the pink region, we're missing 2, 3, or 4. In the orange region, we're missing 2, 3, or 4. This is a red band. Again, it has to be either 1, 2, 3 or 2, 3, 4. So we're not missing. We're in yellow. We're missing 1 or 4 or 6. This is a red band. It cannot be 0, 1, or 6. So this is 2, 3, 4, 5. This can't be missing a 6 here in row 3. So we must be missing a 2, 3, 4, 5. So we have to have a 6 here. So this must be 6, which means we're missing a 5 in the... Oh, this was missing a 6 anyway, so this 0 must be missing a 1 through 4 here. Pink is missing a 2, 3, 4. But it's also missing 2, 3, 4 here. However, cannot be the same digit. So this digit is the one that's missing in the pink. So let's mark that as A. A is missing in pink. It cannot be the same one as missing there. So this A has to be one of these two, which means the 1 is here and the A is here, which means this B is missing here. So this cannot be 3. This B is the same as this B. And this is A and C here. So this is C. So this must be A, B, that's C. B must be missing in... A is missing in row 1. Or A is missing in the pink region. So that's A. Therefore, A cannot be missing here. It has to be B missing here, which means A has to be one of these two. Since A is one of those two, this can't be A. Therefore, this must be B. Cannot be 3 here, then. In yellow, we have already 2, 3 guaranteed on this one. So orange has B and A is missing C. Okay. So orange is missing C. Hmm. This is guaranteed to be either 1, 2, 3, 2, 3, 4, or 3, 4, 5, guaranteeing a 3 in one of these cells here. So that means this cannot be 3, and we're not missing a 3 in column 1. B is here. So this is missing A or C here. So B is not... Okay, so this is missing A or C in column 5. In column 3, we're also missing A or C. So for one thing, these are specifically different digits. We don't know which is which. So... Okay, we're missing B in row 1. Digit in the top left is different. It's a region number, so this cannot be 5. Because we have already a 5 as a region number, a 6 as a region number. That eliminates 5 and 6. This is 2, 3, 4, A. This cannot be B, so this must be C. So this is C here. We're missing then a 5 in row 3. So this cannot be missing 5. This is C. We could be missing a 5 here. I don't know why we limited to 5. So we have that as the upper left. A, C. B cannot be here. So B has to be the upper left corner of a region. That means it has to be here as blue. So then this must be blue. If this is blue, that eliminates red from accessing here. So this cannot be red. So this is blue. So we got blue, blue. This can't be blue. This is red and red. And red must go here. So that's red, which means this can't be blue. It's yellow. So this is done as a region. And this is B. So this is B, which means this can't be 3. This cannot be B. It cannot be C. This must be A, which means we're missing C here. We must be missing A here. So we're guaranteed a 5 in one of these. Okay. No 5 is missing here. We are not missing a 6, so we are missing 1 or 4 in yellow. This is missing A or C. We have B here. So one of these is 3, which is fine. This is C. We have A here. This must be 1 then. So this is 1, which makes this 4, which makes the B's 2. So all the B's are 2. We don't know what C is. So no 2 here. No 2 here, no 2 here. This is 3 and 4. No 2 here, no 2 here. This is 3. So C is 3. We don't know what these are. So C is 3. A has to be 4. So this becomes a 3-4 pair, which eliminates 3 and 4. That's missing in the rest of the columns. A's have to be 4. So A is 4. This cannot be 4 here. This can't be 2 or 3. It's 4, which makes this a 2-3 pair. So 4 eliminates 4 here, so that's 3 and 4. 3 eliminates 3 here, so it's 2 and 3. We're missing 4 in column 3 and 3 in column 5. We're also missing 1 in column 4. This can't be 2 or 3. We're missing a 4, so this is 1, 5 as a pair. This must be 3, 4, and 5, which forces this to be 1, so we're missing 2 here. We're missing 1 in yellow and 6 in blue. So we're missing 2 in column 1 and 5 in column 2. Shoot, there's no actual checking for these. Let me check to see. Well, let's see if it has any error, any checking. Nope, no actual solution checking. But let's just check. Doppelganger, or chaos construction. There are 6 regions of 6 cells. We have 1, 6, 5, 4, 3, 2 as the leftmost of the topmost digits. 1, 6, 5, 4, 3, 2, which is all different digits from 1 through 6. We have 0 through 6 here, 0 through 6 here, 0 through 6 here, 0 through 6, 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 0 through 6 here, 0 through 6 here. Green is missing a 5, which it is. Pink is missing 4, which it is. Yellow is missing 1, which it is. Orange is missing 3, which it is. Red is missing 2, which it is. Blue is missing 6. Okay, are the zeros all missing this different digits? This 0 is missing 2, 4, and 1. This is missing 6, 2, and 5. This 0 is missing 5, 1, and 3. This 0 is missing 4, 3, and 6. This 0 is missing 3, 4, and 6. And this 0 is missing 1, 5, and 2. So Doppelganger satisfied. Renban and German Whisper, or Whisper 5. 0 and 6 is 5 apart. 5 and 0, 6 and 1. 5 and 0, 6 and 1. 1, 0, 6, 6, 0, 5. 0, 6 there, that's satisfied. 1, 2, 3 is a Renban. 2, 3, 4 is a Renban. 2, 3, 4 is a Renban. 3, 4 is a Renban. 3, 4, 5 is a Renban. And these are all part of the same region. So are these, so are these, so are these, so are these, and so are these. As are these, as are these, and these, and this. So duck soup is solved. Apologies, actually. I didn't actually say who actually created this. This was by Kafka Farnham. Um, Apologies for that. We're kind of far in, anyways. Let's continue with the other puzzles. We have Sawtooth. Okay. Again, these can only be 0, 1, 5, or 6. Okay. 0, 1, 5, or 6. These are the same set. So these have to be different sets. And this is the different set also. So this is the medium gray, medium gray. We have all 4 digits here, so this must be 2, 3, and 4. 2, 3, and 4, and we're missing 2, 3, or 4 in row 2. This is a Ren band, so it must be all the digits from it's 1, 2, 3, 4, 5, 6, 7 in length. So it's all the digits from 0 through 6. Okay. These, interestingly enough, are part of the same region. If we did not include that, the problem is to orthogonally connect this, it would block this from a region. 1, 2, 3, 5, I don't even know how that would work. It just doesn't. So this has to be part of a region with these, I think. Right? You can't ignore this because then it would form a region by itself of not enough, it would be less than 6, which is not allowed to get around here. So to go here, right, to get around this, we have the same problem. It would form a region itself less than 6, which is not allowed. Same with that. So this has to be, these are all part of the same region. Cannot be part of this because then that would be part of its own region. Same as this, it cannot be part of that. So these two are the same. These two are the same. These two are the same. Technically, you could do something like that. That's possible. These have to be part of the same region. Otherwise, it's just not going to work. Okay, it'll block that. So this must be blue here. This could all be part of that region. That's fine. How about this? You could do something like this. You could just connect there. These... We don't know. You could do something like that. No, you can't. So how do you connect? So can this be part of this? I don't think so, right? If it tried to, 1, 2, it can't be part of this because then it would have to include that, but then it has to include that. And this would be 7 in size as a region, which is too large. And if we can't go around there, 1, 2, 3, 4, 5, 6, because we still have to connect to there. So this is blocked as a region. So this has to go this way then, guaranteed. This could go out to here. Or do something funky like that. Okay, so it could go there. This could do something like this, maybe. Yeah, that seems feasible too. Can this ever go this way is kind of the question. So if it connects to here, 1, 2, can't be 4 because then we need 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That's too large. So yeah, so this cannot be part of that region. So this has to go this way. And it's probably blue, but we don't know. I guess we can make this pink here. And this will make orange. This is all orange. It could be part of blue, though. Hmm. Hmm. This doesn't have the upper left corner, though, right? Nope. Hmm. Um. Hmm. Um. So this could all be one region. So otherwise, this is all blue, and then this would be also all blue, possibly, with one possibly going there, one possibly going there. Hmm. Ah, wait. If it's not here, then this blue has to go this way because orange has to get out and it can't go to here. So if it's blue this way, then this must be orange. Right? 1, 2, 3, 4, 5, 6. That could work. These have to be part of the same region. So it has to be red because it would be blocking anything else. So this is either part of this region or this one. That's interesting. So say it was part of this. If it's part of that, this would have to be 1, 2, 3, 4, 5, 6, which would force this to be 6. So that looks okay right now. Hmm. This is next to 2 unique digits on a Whisper 5 line. So it cannot be 1 or 5, it's 0 or 6. Huh. This could be 0 or 6 also. We don't know. Hmm. This is 1 through 5 here to be consecutive. Hmm. What other ways do we have? So, if this is all blue, then this must be red here. Ah, and that would not work. So if we try to have all blue here, so again, if this is not blue, orange has to go this way, and it cannot connect to here because that's too large of a region. So it would have to connect through this way then, and then this way. And blue would have to go here, but then where would red be? I guess red could be up to there. That is possible. Oh, but that fails. So, okay, if orange is here, that means blue is here. But then red has to go here. But then this is blocked off from this cell here because orange would be this way, blue would be here, red would be here, and this couldn't orthogonally connect to this cell. So this cannot be blue here, therefore this is all blue here. So that's done as a region. So it has to contain 0. So we have to have 0, 1, 2 as part of it. So again, we have green. I guess this could be orange again. Well, maybe just keep it as pink. Green, pink, orange, red, yellow, blue. So we're missing 3 through 6 in blue. Can't wait. We have 0, 1, 2 as one set of red band. The other one's either 3, 4, 5 or 4, 5, 6. So we're missing 3 or 6 in blue. Can this be part of this? 1, 2, 3, 4, 5, 6. Yes, possibly. Okay. Hmm. Okay. Hmm. So these are all unique here, guaranteed, because they're on the Ren band. Well, they're all unique because, but basically, whatever digit is not in these two cells for these 3 cells must be missing from that row there. Um. Hmm. Hmm. So if this is 5, it could go red up there or red down here, if that's the case. You could have 1, 2, 3, 4, 5, 6. That's possible. Hmm. Hmm. Oh, I don't think that works. So say we had tried to go. So this is part of this region, right? So then we have 1, 2, 3. It has to connect without having getting 2 in the region. 1, 2, 3, 4, 5, 6. But if we tried to do that as 6 this way, how does this form a region? Well, this has to connect through here. So then this is all part of a region. We have 1, 2, 3, 4, 5, 6. But then this is blocked off. One of these is going to be blocked off. So this cannot be the same region. So this is definitely a border there. 4, 5. But you could have 1, 2, 3, 4, 5, 6. Hmm. Excuse me. Hmm. We are guaranteed one of these is the medium 0, 6 here. And the other one's the medium 1, 5. So that means the remaining digits in column 1 are 1 through 5. Okay. Hmm. Okay, how does this connect? The geometries of this are kind of painful, but I don't know. I'm not sure what else you can do. Oh, that's interesting. So at least one of these has to be with this. It could be two. So this is guaranteed to be part of the same region. Because there's no other... This cannot be part of pink, because that's already 5. And therefore has to be part of this cell. Because of that, this can't be 1, 2, 3, 4, 5, 6, 7. That's too large. It can be 1, 2, 3... 1, 2, 3. It can't go 4, 5, 6, 7. That's too large. So I think it has to go this way. Yeah, it can't be part of this. That's too large. 1, 2, 3, 4, 5, 6, 7. Can't go down all the way past here. So 1, 2, 3, 4, 5, 6, 7. So can't go past here. So this is 5 at most, which means it must be part of this. So it has to be part of this. So this is green, cannot be part of here, because then that's too large, so it must be part of this. So this must be part, this is done. That's done as a region. Which means this can only be pink. So that's done as a region. This, I guess, will make orange. This has to connect to here. But this is part... Okay, so this must be part of orange. So this is all orange. 1, 2, 3, 4, 5, 6. Therefore, this must be a region here. And cannot be part of this. Why couldn't it be yellow all the way there? Maybe it could be. Oh no, because it has to include that then. Right. So then this is all part of yellow, and this must be red. Okay, so that's done as regions. Okay. That's done. So what are we missing? These two digits must be these two digits. So these are the other medium and dark. So we have a 0, 1, 5, 6 quadruplet in the green region. So this cannot be 1 or 5. This is 2, 3, or 4. We're missing 2, 3, or 4 in the green region. One of these is the dark 0, 6. We're not sure which. These are 0 through 6 as a quadruplet too. So this cannot be 0 and 6. It's 1 and 5. So this is next to both dark 1, 5 and 0, 6. So this must be the medium 0, 6, which means this is the medium 1, 5. This cannot be 1 or 5. So we're guaranteed this is a red band, so it's either 2, 3, or 3, 4. So this must be in yellow. We must be missing 2 or 4. Okay. What does that mean? Okay, so this digit cannot be the same as that. So this 2, 3, or 4 must be one of these two digits here. We're not sure which, though. Okay, so we're going to mark that as A. So these 3 digits must match these 2 and that one. This. Well, we figured out the regions. The problem is I don't know how to determine which number is which. We're guaranteed a 3 here, so we're missing 2 or 4. This obviously cannot be 0, 1 or 5, 6 because we're guaranteed 1 of 0, 1 here, 1 of 5, 6 here. So this must be 1 through 5. We could have 0, 6 there. I'm not sure. What else do we have? Hmm. Oh, we know the 0 in row 1 has to be part of pink. So the 0 in row 1. So if this were A, that means the 0 in row 1 would be missing the same digit as it's missing in the pink region, which is not allowed. So this cannot be A. This has to be A here. And it's 2, 3, or 4. Because it cannot be here. It must be on this red band, period. And if it were here, again, you'd be the 0 in this row would be missing the same as the 0 in the pink region, which is not allowed. So that means these are all part of the pink region. The 0 is part of this pink region, and it must be missing this digit here. So whatever is B is missing in row 1. Or I guess we should make it Z. We'll make it Z. This will label B. B cannot be on this red band, so it has to be there. And it has to be in the pink region. So the pink region is missing this cannot be A. It has to be one of the digits on this red band and can't be any of these because they're in the same region. Can't be A again. Again, if this were A, again, this can't be A because they are in the same region. If this were A, the pink 0 would be missing this digit here, one of these two digits, and whichever digit it's missing, it would be missing the same one in the row, which is not allowed. That's the reason why this can't be A. This is a zeta or a Z, which basically is missing in row 1, but it's not missing in pink. Therefore, this must match here and is A. This is not on the this cannot be on the rest of the ren band, but it's guaranteed to be part of the pink region because it's not missing in row 1. Or actually, it has to be, yeah, it can't be here. So it has to be here. So that's B. Okay. So this is missing. This must be B. This could be A, though. So this cannot be 0 here. Hmm. It's 1 through 6, obviously. Which means in row 2, where is the 0? It has to be in the green region, which means this cannot be 0 here. Since this can't be 0, this can't be 5. That's interesting. So 0 is one of these 3 digits. We cannot be missing C. So in the green region, we're missing a C, 2, 3, or 4. So this has to be C. So this must match, it's basically Z. So we must be missing 1, 5, or 6 here in row 2. So this is C. Z is the same. This is C as the same. So this must be 0, 1, 5, and 6. Okay, that doesn't tell us very much. Uh... Hmm. Hmm. This is kind of tough, actually. Maybe it is actually hard difficulty. Hmm. If this is 0 and 5. Sorry, 0, yeah, 0 and 5. Hmm. We have B here. So this is A or C. We're not sure which. Obviously, this is A or C. Hmm. This is obviously B or C. Does that help us? I'm not sure. Um, um, if this is 1, uh, um, hmm. Oh, that's interesting. We are guaranteed the orange 0 has to be one of these cells here. So that means this cannot be 0 here because we're guaranteed a 0 in the orange region and in the yellow region in rows 3 and 4. And that accounts for all the zeros in rows 3 and 4. So this cannot be 0. It could be 1 through 6 there. You could have 0 here, or 3, 4, 5, and 6. This could obviously be 0, 1, 2, or 3 through 6. So that's not helpful. Hmm. How do we figure this out? This one's harder, I feel. Hmm. 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 Ugh. Phew. Oh boy. Hmm. So pink is missing 2, 3. Okay. Pink is missing 2, 3, 4, which is A. So yellow must be missing B. So this cannot be B. This has to be C then. This can't be C. This must be A. So B has to be 2 or 4. So this is missing C in column 2. Um, so we're missing C in column 1, or row 1 in column 2. This cannot be 0 then. Because if this were 0, we'd be missing the C in the green and C in column 2. So since this can't be 0 here, this can't be 5. So therefore this can't be 6 here, right? If this were 6, that would force this to be 5 to be the same set, right? 0, 1, or 5, or 6. And if this were 6 again, this would have to be 5, but it can't be 5 because this can't be 0, because it would be missing C in the green region and C in column 2, which would be where it is. So this cannot be 6, which means this cannot be 1 here. So this is 0, 5, or 6 here. So we're missing... Okay, so then these orange and red are missing 1, 3, and 6. Wait, can't be 3. This has... So blue has to be missing 6. Because we have a 2, 3, 4 triplet in the regions that we're missing. So then orange and red are each missing 1 or 5. So we are missing 6 in the blue region. So it has to be 0, 1, 2, and 3, 4, and 5. Okay. That means, yeah, we have a 0 through 5 sextuplet in row 5, which eliminates 0 through 5 in the rest of the row. So this cannot be 0 through 5. We have to have 6 missing in row 5. So we cannot be missing 6 in any other row, so we must be missing 1 or 5 here. And it must match this cell there, because that's the only one missing from row 2. And it's going to be in the green region, so therefore this can't be 6 here, which means this can't be 1 here. This is 0 or 6. This is 1 or 5, so then this has to be the dark 1, 5, which means this is the medium 0, 6, which means this has to be dark 0, 6, and therefore must be dark 6. So all the dark 0... This has to be the dark 6, and that must match it. So then this is 6 next to 1 and 0. This is 5 and 0 there. That makes this 6 and 1, which makes this 0 and 5. Therefore, this is 5 here. So that's all the coloring there. We have all the medium. Okay. So this 0 is not missing a 1, it's missing a 5 here. It's missing green, 2, 3, or C. This is not 0 here. It cannot be 0 or 5 because of 0 or 5 in the column. No 5 here, no 0 or 5 here. So this is 3, 4. This must be 3, 4, and 5 as a Renban line. This can't be 0, no 3 or 4, no 3, 4, 5, no 3, 4, 5. So this is 0 here. This can't be 5 because of the 5 in the row. So where's the 5 in the on this Renban? It has to be here. We're not missing 1 here, so we're missing 2, 3, or 4 here. So this must be A or B we're missing here. This can't be missing 1 here. No 1 or 5 here, so this is B. Which means we're missing 5 in column A, or 5 in column 1. So 5 cannot be here, cannot be here. Where's 5 on this Renban? It has to be here. So that's 5. C is 2, 3, or 4. One of these is 0 on this ren band, so this must be 0, 1, and 2. Cannot be 1 because of 1 in the row, so this is 0, 2 as a pair, which forces this to be 1. That eliminates 1 in the rest of the column, so this can't be 1. This can't be 1. This can't be 5. We are guaranteed a 3 here. So, B, yeah, we already knew B was not 3. It's 2 or 4. We have a 2, 3, 4 triplet in the red region. We are not missing a 5, so we're missing a 1 in the red region and a 5 in the orange. So this is 0, 1, 2, which eliminates 0, 1, and 2 in the rest of the orange region. So this must be 3, 4, and 6. This is A. So A is not... C is guaranteed to be here. A cannot be here, so B has to be one of these two, which means B is 4. So this is 4, which means this is a 2, 3 pair here. This is not 4. Not this 4 eliminates 4 here. So A's are the 3's. A is 3. C is 2. Okay. This can't be missing 2 here. It's missing 3 or 4. This is missing 3 or 4 because this 3 eliminates 3 here. So this becomes a 4, 6 pair, which eliminates 4 and 6 in the rest of the row. So this can't be missing 4. It's missing 3. This can't be missing 3. It's missing 4, which means this is a 3, which makes that 4. This can't be 3 or 4. It's 2, which makes this 2 and 3. 2 eliminates 2 here, so it's 1. This can't be 1 or 2. It's 0. This can't be 0 or 1. It's 2. 2 eliminates 2 here, so that's 0 and 2. 0 and 1 eliminates 0, 1 here, so it's 6, which makes this 0, which makes that 1. 4 eliminates 4 here, so it's 6 and 4. And that leaves this digit. We're missing a 1, so this is 6. We're missing a 1 in row 6. We're missing a 3 in column 3. We're missing 6 in column 4. 1 in column 5, and 4 in column 6. Okay, these are 5 away, 5 away, 5 away, 6 away, 5 away, 5 away. 2, 3 forms a Ren band. 0, 1, 2, 3, 4, 5, 6 forms a Ren band. 0, 1, 2, 0, 1, 2, 3, 4, 5 form a Ren band. 2, 3 form a Ren band. These are part of the same region. So are these, so are these, so are these, and these, and these, and these, and this, and here, and here. This 0 sees a 3, a 2, and a 6. These are all 0 through 6, 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 0 through 6. Same here, same here, same here, same here, same here, same here. Pink is missing 3, green is missing 2, orange is missing 5, yellow is missing 4. Red is missing 1, and blue is missing 6. This 0 again sees 2 in the row, 3 in the region, and 6 in the column. This 0 sees 5 in the row, 3 in the column, and 2 in the region. This 0 sees 4 in the row, 1 in the column, and 5 in the region. This 0 sees 3 in the row, 2 in the column, and 4 in the region. This 0 sees 6 in the row, 5 in the column, and 1 in the region. And this 0 sees 1 in the row, 4 in the column, and 6 in the region. So that's done. Okay, now travelers. Okay, so let's reset this. Okay, each purple line contains a series. So we don't have the two ends of a Ren band line here have to be in the same region. We just have dots. So this can be 1 less than the number of regions which could be part of, which could be 0 or 1. So this is 0 or 1. This is 0, 1, or 2. Right, because this could be part of 3 regions. 1, 2, 3, 4, 5. 1, 2, 3. So this is 0, 1, and 2. So we have all the 0, 1, 2s in circles. So these have to be 3, 4, and 5. Which one can be 5? This cannot be. It's 1, 2, 3, 4, 5 possible regions. So this has to be 3 and 4. Same with this. 1, 2, 3, 4, 5 possible regions. So this is 3, 4 as a pair, which forces this to be 5. So then these are all 6 distinctly different regions. Okay. So then this is a region. We have 3 or 4. One of these is all different regions. So this must go down. So we have green. So green, pink, orange, red, yellow, blue. These are different regions. So this is, okay. We have boundary here, boundary here. This is a different region than this. So we're going to make that pink here. These are all unique different regions. So orange, I'm going to make that blue, yellow, and red. So we have a 5 here. That's interesting. So 0, 1 must be with 0, 1, or 2. And we're guaranteed a 1 here. This has 0, 1, or 2 and cannot be 2, 3, 4 or 3, 4, 5 or above. So it could be 0, 1, 2. It could be 1, 2, 3. It cannot be 2, 3, 4. So we're guaranteed a 1 and a 2 here. Hmm. Hmm. This can't be 1 or 2. We have 0, 1, 2, 3 as possibilities. This cannot be 1 or 2. It could be 0, 3, 4, or 6. Okay. One, 2, 3, 4, 5, 6. Minus 1 is 5. Oh, this cannot be 3, 4 as a pair. So this must be 0, 1, 2 as a Renban. Right? Because this cannot have 3 and 4. You can't have 2, 3, and 4 here, which is the maximum this could be. You can't have 1, 2, 3 here because 3 can't be here. So this is 0, 1, 2, which means this cannot be any of 0, 1, or 2. It's 5 or 6. This is 0, 1, 2, 5, or 6, possibly. green can never be part of all of these regions. Can pink actually get there? It could. I think pink has to get to here, right? Um, this, none of these cells can ever get to green, right? Green is only 6 at most, and it can't be a full 6 all the way down. So green has to go to one of these. Can this be yellow? No. So if this were yellow, okay, so this can't be all green because again, we have the same problem that I said before. If you have a row or column which is all one region, the 0 in that region is going to be missing the same digit in the column and the region, which is not allowed. So this can't be green for that region. And if we try to make it yellow, there's too few cells in the remaining cells here to form 2 full regions. So this has to be red. So this is guaranteed to be red. You could have multiple greens here, I guess. This must be a set of 5, so either this or this has to have a red. And if we tried to go red there, I guess it could be that. That could be red. But this, no matter what, this has to be red, right? If we try to make this yellow... no. The problem is red has to be part of the set of 5 different regions that the Renban is on. And if it's here, obviously it has to get some connection, and then if it connects this way, this is going to be red because it can't be another region. Obviously, if it's this one, you have to connect here, and you can't do this without this being part of multiple cells. Yeah, this has to be red, period, basically, is the point. Okay. Blue has to get out somewhere. So if we block this off, there's no way that this forms a region. So this must be blue, right? If we try to do that... So if we block that off, we have 1, 2, 3, 4, 5, 6 guaranteed, and green would not be a region, so that's not possible. So this has to be blue. Orange has to connect to one of these. Oh, this can never get to... This can never get 5 different regions. Because orange has to connect some way. Blue has to go that way. So orange has to go this way. Which means pink, this has to be the one that has 5 different regions. So this is 4, this is 3, this can't be 3. This is 0, 1, 2 as a triplet. Which means this can't be 0 or 3, it's 4, 6. Pink has to be able to get to this part to make this have 5 regions. So we have region. This must be orange to get access. This must be blue. This must be yellow. And this has to be red. Okay, so this is 5. Pink is done as a region. So this is all within one region, so this must be 0. So we have 0 here. This is 0 and 1. This can't be 0. This can't be 0. We have 1, 2, 3, 4, 5. So border here, border here. Um, hmm. This is at least 2 regions. So we have 3, 4, 5 in the red region, so this can't be 5. 4 cannot be here on this red band, but we need a 4, so one of these two is 4. 5 length Renban. So again, so remaining digits of row 1 have to be 2 through 6. This can't be 4 though. So we're missing 2 through 6, but no 4 in row 1. This can't be 5 because of the 5 in on the Renban. For 5 length Renban from 0 through 6, you have 0 through 4, 1 through 5, or 2 through 6. So you're guaranteed 2, 3, and 4? Is that right? Okay. So this 0 is missing 2, 3, 5, or 6 in row 1. It cannot be missing the same digit here in the pink region. So this digit must be the same as this one. Okay, we have region here. So this is either 2 regions or 2 regions or 3 regions. It's crossing through here. This is 2 or 3. One of these has to be green. 1, 2, 3. On the 5, we have to have a 1 available. Definitely. So one of these is 1. Do we have to have a 0? No. So this cannot be 1, 4, or 5. It could be 0, no 3, 2, no 3, 4, 5, or 6. That's interesting. These are different values, and it cannot be 0, 1, or 2. So this is 3, 4, 5, 6. No 3. This is 4, 5, or 6. Because these have to be different values of 1 or 2. So this is 2, 3, 5, or 6 here. Um, this is the digit that's missing from pink because it cannot be the same as this because then the pink and row 1 would be missing the same digit. So we're going to make this B. So this is missing B here, which is 2, 3, 4, or 6. Because this A matches that. Okay. We're guaranteed a 0 here. So this cannot be 0 here. Hmm. Yeah. Huh. This cannot be 1 because of 1 in the column. This can only be 3. If this is red, this is yellow. Oh, can this ever be 3? No. Red, yellow. Yeah, orange can't reach, so orange is not part of it. Blue, it could be if this is blue and this is yellow, but then this would not have 3 regions that it goes through. It'd be just 2. And if we tried to go blue around here, 1, 2, 3, 4, 5, 6 does not reach here. So this must be 1. And this has to be 2. So no 2 here, no 2 here. This is not 2, so this is not missing 2 there. So this must be separate regions. This is 1 because it's 2 regions. So separate region here. It's either blue here and this becomes yellow, yellow, yellow. Or blue's not part of this, and this must be yellow. This would have to be red. And this would be yellow and yellow here. So either way, this is yellow. Since this is yellow, we have 1, 2, 3, 4, 5, 6. So this cannot be yellow here. So this is border. This can, well, it could be 1. This is yellow or blue. So either this is blue, which forces all of these to be yellow, or this is red. This must be yellow here. And this could be red. We have yellow here. We have to have 1, 2, 3, 4. It could be 5, 6, maybe. Red is missing 1, 2, or 6. So this is definitely yellow there. Orange can go down once there or once here. This could obviously be green. So green can only be one of these. So this must be all green. So that's done as a region. Therefore, this cannot be This can only be one red here, so therefore this is guaranteed to be red. So since this is red, this cannot be red. Well, this could be red here. But this must go yellow there, so this cannot be blue. Blue does not have enough space, so this can't be orange, so this must be blue there. So this is yellow. This is boundary. Boundary. That forces this to be orange here. So no green. That's done as a region. And this is either red and green, or this is blue and green. This is yellow or blue. We're not sure which. This can't be 1 because on the Renban we already have a 1. This is 0, 2 as a pair, which eliminates 0 and 2 in the rest of the row, so this can't be 2. This is 1 or 6 here. So this is 2 here. Yellow's not missing 1, so it has to be 2 through 6. In column 2, we're missing 4 or 6. We are guaranteed a 0 in column 1. So, and this can't be 0 because of the 0, 2 pair in the row. So the 0 in column 1. So that means it must have a 1 in the green cell in column 2. But the 0 in the column 1 cannot be missing a 1 because it's, or sorry, cannot be missing has to be missing. It's not, okay. Say this was a 1 here. Then we know the green has to have a 1 here in column 2 because it can't be 0 because the 0 has to be in one of these cells in the green region in column 1. So if this were a 1 here, the green region would be missing a certain digit. This would be 1, so that would match the 1 that's in the green region in column 2, and therefore the 0 in the green region and in column 1 would be missing the same digit, which is not allowed. So this cannot be 1. This has to be 6, and this must be missing a 1. 6 eliminates 6 here, so it's 5, which means this cannot be red. So this is yellow, which means this can't be yellow, that's blue. So yellow and blue are done as a region. So we know these are done. Blue is done as a region, which means this must be red, and this must be green. So since this is green, it cannot be 0, it's 1, which forces this to be 0 in the red region. Therefore, this can't be 0 in the red region, it's 2, which eliminates 2 here, so that's 0. There's no more 0 in the yellow region. This can't be 1 in the yellow region. This can't be 1 in the blue region. Where's the 1 in this Renban, which we do have to have, because it's 0 through 5 or 1 through 6. So therefore, this must be a 1 here. So in the red region, we're missing a 1. In column 1, we're missing a 1. So this cannot be 6 here. So B is 2, 3, or 4. On the Renban, 5 in length, you can have 0 through 4, 1 through 5, or 2 through 6. You're guaranteed a 2. And 2 cannot be here. On this Renban, 2 can't be here, so this must be 2 here. Which means this can't be 2, so we have to have a 2 in one of these two cells. 2 eliminates 2 here. On the 6th length Renban, we need a 2. Can no longer be any of these because this must be 2. So it has to be here. So B is 2. That means these are both 2. This has to be 4. We are missing a 2 in the pink region. It's 3, 5, and 6. This can't be 2 because of 2 in the orange region, so this must be 2 here. We have all the 2's already in the column, so this must be missing 2 in column 6. We have 1, 2, 3, 4. Sorry, 1, 2, 4, 5. We have to have 0, 3, or 6 remaining. This can't be 0 because of 0 in the row. So where is the 0 in column 3? It has to be here. So this is 0, which forces this to be 0 through 5. So this is 3. There's no 3 here. That's 5 or 6. We're missing 5 or we're missing 6 in column 2. So we must be missing 5 in column 3, which means this can't be 5. That's 6, which eliminates 6 in the rest of the pink region. This can't be 6. We're missing 3 or 5 in row 1. Remaining digits of column 1 are 0, 3, 4, and 5. This cannot be 0, 3. No 0 because of 0, 3's in the row. This can't be 5 because of 5 in the row. We're missing a 1 in row 6. Where can 0 be in row 5? Can't be in the yellow region because of 0 in the region. Can't be 0 there because of 0 in the column. So 0 has to be here. So that eliminates 0 from being here. We have 5 zeros. We know where the last 0 has to be. It has to be there. Okay. Remaining digits in row 5. So we're missing... We already have 2, 3, and 5 in the yellow region. This is 4 or 6 then that we have. This cannot be 4 on this red band because we already have a 4, so this is 6, which means this is 2, 3, 4, 5, 6 on this red band. This 5 eliminates 5 here. We have 2 and 3. We need... It could be 0 through 4, but there's no 0 on this red band. So then it's 1 through 5 or 2 through 6. So one of these is guaranteed to be 5, which means this cannot be 5. This is 3, which makes this 5. That makes we're missing 5 in row 1. So again, it could be 1 through 5. So it would be 1, 5 there, or 2 through 6, which means it could be 2, 4, 5 with 4 or 6 here. 1 cannot be here because of 1 in the row. Okay, so 5 eliminates 5 in the rest of the row. We're missing 3, 4, or 6 in row 2. We're missing 2 in row 3. So this can't be 2 here. It's 3, 4, or 6. 5 here eliminates 5 here, so this is 3. That eliminates 3 in the rest of the row. This becomes a 4, 6 pair, so we're missing a 5 in the orange. Remaining digit here cannot be 1, 2, 3, 1, 2, 3, 5, 6, so it has to be, or 0, so this is 4, which eliminates 4 in the rest of the red region. We need a 4 in this red band. So this has to be 4 here, which makes this 6, which means this can't be 6 or 4. It has to be 5. 5 eliminates 5 here, so it's 4 and 5. That makes this 3. This cannot be 5. It's 1 or 6 here. Okay, so we're missing a 6 in row 2. We're missing a 3 in column 5 and a 4 in column 4. This 6 eliminates 6 here, so this is 1. We're missing a 3 in row 5. We're missing a 4 in the yellow region. We're missing... This has to be missing a 4, so this must be 6. Which means in the blue region, we're missing 3. In the green region, we're missing 6. Okay. So let's see the rem bands. This is one less than the region it's in. So one region minus one is 0. Two regions minus one is 1. Three regions minus one is 2. Four regions minus one is 3. Five regions minus one is 4. And six regions minus one is 5. The rem band 0, 1 is consecutive. 0, 1, 2, 0, 1, 2. 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5 here. So the rem bands are done. And let's see the doppelganger. We have row 1's missing a 5, row 2's missing a 6, row 3's missing a 2, row 4's missing a 4, row 5's missing a 3, row 6 is missing a 1. Column 1 is missing 1, column 2 is missing 6, column 3 is missing 5, column 4 is missing 4, column 5 is missing a 3, column 6 is missing a 2. Green region's missing 6, pink is missing 2, orange is missing 5, blue is missing 3, yellow is missing 4, red is missing 1. This 0 is missing 5 in its row, 3 in its column, and 2 in its region. This orange is missing 6 in its row, 4 in its column, and 5 in its region. This 0 is missing 2 in its row, 5 in its column, and 3 in its region. This 0 is missing 4 in its row, 6 in its column, and 1 in its region. This 0 is missing 3 in the row, 1 in the column, and 6 in the region. And this 0 is missing 1 in the row, 2 in the column, and 4 in the region. So that's done. Yeah, I guess as actually thinking about it, this probably was about a hard difficulty for each of the puzzles. I'm surprised we got through so many of them. And this was just a 6x6, so that was pretty tough. Apologies for not, what did I do? I did not cite the setter, Kafka Farnham. Apologies for that. I think because I got too stuck with the labeling all the puzzles. So apologies for that. That was not intentional. None of my mistakes are really intentional. So, but like that's a particularly egregious one. I feel. It's always good to highlight the setters because the setters do a great job of setting, and without them, we wouldn't have these amazing puzzles to actually solve. So it's pretty cool that they do it. So. I really feel bad about not stating their name at the beginning of the puzzle. I usually do, but I think I just got too wrapped up in that there are 3 of these, and then I had to go through all of them. So apologies, Kafka Farnham. You got a great name too, so apologies if that was made things. If you're a little put out by that, I can understand that. So. And I guess that's it. I hope you enjoyed these solves, and I'll see you next time on Frank Puzzles. Take care.